Hey, what's up, everybody? Good morning, good afternoon, good evening, whatever time of day you're deciding to watch this video. So this is a video to help walk us through the Earth-Sun relationships lab. The overall lab, I think, is relatively straightforward, but what we're going to do, which might be a little bit more complicated, is work with something called an analemma. And so I'm going to walk us through that. What we're going to cover today and what we covered in the previous lab is kind of working our way into our next lab, which is going to be looking at a little bit more specifically seasons and temperature variation around the world. And so kind of all of that building into this next lab. Again, as always, try to work your way through as best as you can, answering all the questions along the way. And then reach out to me if you need any assistance. Again, my office hours are always open. My email's always open, as well as you can text me anytime also. So this should be roughly what you see for the Earth-Sun Relationships Lab. As always, please make sure that you are following all the directions that are indicated here. And of course, gotta shout out special thanks to my pal Rachel Cunningham, who's your professor here. Maybe she's even your professor for Geography 100, but she provided the basis for this entire lab. So you can read through the overview and objectives on your own, and kind of working through this idea of something called declination and analemma. So we know that the Earth is revolving around the sun. At the same time, our planet is also revolving around its axis. This helps determine sun angle on our planet. And that's something that basically that we call declination or a subsolar point. So this table here is not something you need to fill in. This is just information for you, looking at 4 very important dates: the latitude, and the name of said latitude, and the holiday of said date. So these are really, really important dates. I encourage you, if you don't have these already memorized, give them a good old memorization. It'll be very, very useful moving forward. And also whenever you come across these days, you can be like, woo, happy spring equinox, everybody. Or whatever, however you want to go about that. So your first couple questions here pertain to this first table. And then now we're going to utilize this thing called an analemma. So I'm going to post this PDF on our Canvas page so you can find it underneath the lab. But basically what we have here is a sort of figure 8-like structure where we see a red line here and some months are indicated in these blue dots. We're going to ignore the numbers on the top and on the bottom. And I do also have to give a little bit of a disclaimer that this is for the year 2014. You know, we do kind of wobble a little bit on our axis. We're not always at 23.5 degrees, and there's a little bit of fluctuation here. But it's really hard to kind of remake these things over and over each year. And a former student of Rachel was kind enough to provide her with this analemma for 2014. There's not apparently very many of these that are like free access, which is kind of silly. But this is a tool that is used by geographers in the field, and so we want to be able to give you the opportunity to work with a tool that is utilized by real-life geographers in the wild, if you will. And then, anyway, going back to this imagery, the numbers on the left and right are the same on both sides, but they are basically indicating our latitude in the northern hemisphere for the top and in the southern hemisphere for the bottom. So, and you can basically follow the months around here. So basically, like if I were to start with May, then we go to June, July, August, then September's here, going through winter, etc., and then back up into spring. So that's how to sort of, the baseline on how to kind of read this particular image. So if we are given a particular declination or a particular latitude, and we follow that latitude all the way across, then that will give us two specific dates. And so that will give us essentially the declination date or subpolar point date for that particular latitude. And so I give you an example in the lab itself. So on what day of the year is the declination at 14 degrees south? So first thing we want to do here, and by the way, there's never ever any shame in reminding ourselves, to never eat soggy waffles. If you forget maybe which way is north, which way is south. So our, in the example, I said 14 degrees south. So I'm going to zoom in here a little bit just so, south meaning we're going to be on the bottom of this particular figure. And so what we're going to do here is then on our left or right side, find that number 14 because the example said 14 degrees south. And so what I'm going to do is basically I'm going to draw a line all the way across. So this line's going to disappear. So we'll start over here then. For 14 degrees south, this is in between March and February. And what you can kind of do, or a trick perhaps, is to sort of kind of imagine halfway in between March and February, maybe like right here-ish would be February 14th, right? Because February has 28 days, not 30 or 31. So if we imagine that February 14th being right around here, and the 14 degrees south declination is closer to February than the halfway point, then we could estimate that the date for one of the dates for the declination is maybe February 12th or something like that, right? Something closer to February 1st than February 14th. It's just an estimation. As long as you're getting somewhere in the sort of ballpark, that's what I'm asking for in this exercise. But note that 14 degrees south does not just cross this red line or figure eight at one location. Pew, we got to hang out over here too. So where the 14 degrees then crosses the figure eight is really, really close to November, but not quite to November 1st, but dang near the end of October. So we could maybe estimate either, I would say maybe October 31st or October 30th. Let's see what our lab says here, or I guess here our answer is November 1st. So, it's pretty close right here, right? So as long as you're not saying like November 30th or sometime in December or October 1st, as long as you're getting anywhere within that ballpark, that's essentially what I'm asking for. So I give you a couple of times with the declination changing. Note that if you're taking this in a different semester, some of these numbers may change. So be sure to just follow whatever's on your lab. And then if we wanted to do the opposite, so if we're given a day, we want to find what the declination is. So I'm not going to do the examples that were there. But if I wanted to do, say, let's see, like July, let's do, trying to think of a birthday that I have. So let's do, say, like July 7th. That is my birthday. So what we would want to do here is then find the, or estimate the, where July 7th would be. So I know that July 7th is between July 1st and August 1st. Halfway between would maybe be like right around there-ish, right? So then July, which would be July 15th or 16th. So July 7th would be closer to July than July 15th. So I'm going to estimate July 7th being maybe halfway between there. So if I take this and somehow in a straight line, obviously it's not a straight line, I kind of curved down a little bit, but, kind of trying to estimate, I'm really bad at drawing straight lines. But in between those, then I would say that my line of declination or my longitude of declination would probably be about 22.5 degrees north, right? So it's really, really important to, oh my gosh, I can't, I can't draw worth crap. So 22.5 degrees north would be for July 7th. So again, you just find, estimate the day wherever it is, and then find the declination latitude for each one, or if given a declination, then you can pop on over to the figure 8 to give you a date. And then for your next activity, you're basically going to be doing a bunch of drawing. So if you don't have access to a printer and can't print out a couple of the figures here that I asked you to draw on, no big deal. Just draw on like a blank piece of paper that you have. Try to copy this as best as you can, and then complete the rest of the problems here. So for number 8, I ask you to draw a couple of different circles and lines and such, and X's, and same thing for number 9, just for a different date. And then we go through this idea of tangential rays. So tangential rays are really fascinating because that's kind of like, a really intense angle. And we know that, some places on Earth actually get 24 hours of sunlight, but they're still really quite cold because they're in the Arctic circles. So because they have these tangential rays, even though there's 24 hours, like the sunlight is really, really, really spread out. That basically allows for these areas to still be very cold because that sunlight's not concentrated. And so you can calculate that tangential ray. All you have to do is subtract the latitude given by 90. So in this case, for this example here, on June 22nd, the declination is 23.5 degrees north. Maybe think about what latitude, line of latitude that might be. And then you just do 90 minus 23.5, which equals 66.5 degrees. So what I would like for you to do here is for the images that you drew up above, you're also going to draw another line here, a dotted line. Please make sure to label them. That way you can get credit for this problem. And then numbers 11 and 12 ask you to then indicate where the tangential rays are located. With that, you're going to need to do two things. You're going to need to use the analemma and do a calculation. So just a combination thereof for both numbers 11 and 12. And then lastly, number 13, you're going to do, again, just some more drawing here. And once again, if you don't have access to a printer to print this out, just kind of make your own sketch on a blank piece of paper and complete, draw and label the following, these various lines, estimations of where these lines are at for September 22nd. So that is essentially the lab for this week. So a little bit more kind of like drawing and kind of asking you to fill things in using an analemma. And if you've never used one before, it can be a little bit tricky at first. So be patient with yourself. And again, as always, feel free to reach out if you have any questions, comments, concerns. Office hours are always open. If you're having any tech issues or you want to check something, it's best to send me pictures of whatever you're looking at or doing so that I can help diagnose potentially the issue or check what's going on. But yeah, thank you so much for watching, and I hope you have a delightful rest of your day. Thank you.